This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome again to another in the series, Mastering Mathematics. This is Karen Weston, and a program sponsored on behalf of the Ministry of Education in conjunction with its EBU unit and Center for Mathematics Education and Research. Again, we must not forget there's another part to it too. We're also interested in warrior education. Of course, nothing could have been done without ABS television. Welcome, my audience, to this, another in the series, Mastering Mathematics. What have we been doing? Oh, sorry, yes, you were celebrating. What did you celebrate? Was it the rain? What else did we celebrate? Oh, yes, that independence, 32nd anniversary of our independence. For all those persons who are honored, God bless you and thank you for your contribution to Antigua Barbuda. Did I hear a teacher got honored in that ceremony? All right, we're going to make certain that the next time we are not left out. Today, we are going back again on the technique of mastering mathematics. And we're working with our fractions. And we know we have several types. And we're still on vulgar fractions. And we're doing our operation. I gave you some homework. Did you do them? Right. Don't forget, you can email your answers to masteringmathebu@gmail.com, and do not forget to go on our website, YouTube/Mastering Mathematics, and you will see our solutions there. And do not forget our website, www.masteringmathematics.info. And of course, you can contact me at 783-6971 or the ministry at 462-0192. If you're walking, you can come right down to the bottom of Lower Nevis Street, that lovely pink building near to where you get your Australian ice cream. On the second floor, you can come and make an appointment. Our cameraman is here, my timekeeper is here, and my computer analyst is also in the studio today. So, we are going to bring you this program that we have devised for you. Independence is over. We have celebrated. Those people whom we are celebrating have taught us nothing conquers but hard work. And so we are back on the grind. Did I hear you say that you did those addition and you know what you're doing? All right. Now, I told you that in order to do our addition, where we would have had a fraction, and again I'm using the grain lane just to get some examples. So I could have had 3/4 plus, and it is 3/8. Let's write it up here. 3/4 plus 3/8. And you are telling me that you know what to do if I ask you to add those fractions. Am I correct? Yes. Because what is the first thing we have to do? Right. Our first step would be to find our LCM. And we're going to make certain that you learn the principle. So we're not going to ask you just to look. When you're mature, you can do that. So we're now going, and we say we start from our tables, and it's from the lowest one. And then we're going, we put our numbers down, and we're seeing if the number 2 can be divided equally without leaving a remainder into these numbers. So we'd go right away, and it is a 2 here, and it is a 4 here. So again, we can try 2, and here it would be a 1, and it would be 2. So we're going 2 again, and it is a 1, and it is a 1. And once we have achieved a line where it says all ones, then we know that that is the end of finding our LCM. And so we take the numbers on our side, and we would be saying the LCM then is equal to 2 times 2 times 2, which is now equal to 8. And yes, my bright students would have said, but I knew that, I wouldn't have to go through that. But we're catering for everybody. And we are pretending that we know there's some student, or we know there's some people who would have been learning this for the first time. So we're making certain that everything is well taught, okay? So the LCM then would be 8. And incidentally, if they had to ask you to represent the number 8 in its prime numbers, this would have been what you're writing, okay? And do we know what a prime number is? Did we tell you that? We're calling numbers, we're speaking vocabularies in the mathematics classroom, but are we certain that every child in that classroom understands what we're talking about when we talk about a prime number? Can anybody tell me what a prime number is? Do we know it? Is the fan going to tell me what the prime number is? Can I depend on Asher to tell me what the prime number is? Oh, she named Dummy Arthur, you know, she never answers. I wonder if my cameraman would want to tell me what is a prime number. Okay, what is that prime number?
A number with only 2 factors.
You see? Yeah, this cameraman is not just a cameraman, you know. He's a mathematician too. Take it from me. Factors involved. So when we talk about, write down the word prime number, okay? So any number that has only 2 factors, 1 and itself, is called a prime number. And so we can get some examples of prime numbers. So I would say, I write down the number 1. Is 1 a prime number? Can anybody tell me or answer that question for me? What about my friend behind here, the analyst? Is 1 a prime number?
Well, by the definition, yes it is, because it has 2 factors, 1 and itself.
No, 1 is not a prime number. It has 1 factor, 1 and 1, not 2, not 2 numbers. So again, 1 is not a prime number. All right, we must get 2 factors, 1 and itself. Now, if I gave you the number 2, we just found out that that was a prime number because the factors would have been 1 and 2, okay? And we can go 3, and you would see right away, again, 1 and 3. When we get to 4, what are we going to get for the factors? We have 1, we have 2, and 4. So how many factors do we have here? 3. Can we say that that's a prime number? Is that a prime number? No, because everything is within a definition. How many factors we must have? 1 and itself, so it must be 1, 2. So, probably if I have 1 and 1, 1. All right, so that makes it not a prime number, and this would not be a prime number because we have 3. All right, and then we'd get back here when we have 5, and then that would have been 1 and 5. And that's what we take, 2. So you're not guessing, you're looking and say, how many factors can we get? How many factors? If the number is 2, it's a prime number. 2, it's a prime number. 2 is a prime number. 1, no. More than 2, no. All right? So that is it, clear-cut definition. And that is why we say teachers just need to take a little time, tell the children these things, and don't use words that you don't think that everybody knows. All right? So we're saying then, and this is what we call taking an aside. So you say, Miss Weston, you're teaching LCM. Taking an aside, it comes in, and we cannot pass over if the vocabulary is not known. All right? So we're going to just send you on a little break to say, Lord, that was a mouthful. Miss Weston gave me so many things one time. Take your time. We're still doing our addition. We did our LCM. We showed you the method, how it is done. All right, and I deviated a bit to say that these now are the prime numbers of 8. Having said that, I have to explain what is a prime number. We cannot leave anything hanging, all right? So, absorb that, cool down a bit. Don't say Miss Weston is going too fast. I didn't understand what she meant. So just absorb it. 1, the LCM. The LCM can be expressed as a prime number. Definition of a prime number, it must have 2 factors, 1 and itself. If it has 1 and 1 only, it's not a prime number. So we're going to leave you here where we said our LCM is 8. Go and take a little break. Tell your friends Miss Weston is on the television, and we'll be right back.
To succeed in mathematics, you need to build on what you have learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear a feeling I strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So, let us teach them the way that they learn and help them to achieve their full potential. Right, and as we proceed on this journey and continue to teach mathematics, you know in my brains I cannot help remembering and seeing in my mind's eye my fallen brother, Sean Williams. Let us keep the family in our prayers. He will never be out of my thought. He will always reside in my heart, and there's a special place for him in the history of mathematics in Antigua Barbuda. And the God of heaven will be with us as we proceed to continue the fight and the work began with him involved. To the students at Old Roads Primary School, I say keep on doing your good work. I will be out, as I said, and your projects will be good. Very, very good. All right? So we continue now as we do the addition. So we have our LCM, and of course we're going to be saying, using this denominator, we're going to say 4 into 8 goes 2 times. All right, we can get 2 groups of 4 out of 8. And then the 2 we get, we'll be saying 2 times 3, which would give us 6. So this is now 6 plus 8 into 8 goes once, and 1 times 3 would give us 3. And so we're going to be getting that our answer here would be 9 upon 8. What do we call that fraction? What type of fraction is that? And I want to hear Aisha's voice. Aisha, please tell the nation and the world, what do we call that fraction? No, we can't hear, man. Cameraman, what are you saying? Did you take her voice away? Do you want to help her?
That's an improper fraction.
It's an improper fraction.
Is greater than the denominator.
Thank you. The numerator is greater than the denominator. Aisha was saying that, but I wanted to voice it because she has children and they want to hear their mommy's voice on the telly. All right? So this is now an improper fraction. We can choose to leave it like that, or what else can we make it into?
Make it into a mix.
And we can make it into a mixed fraction. Is that right? So we have a whole number and a proper fraction. Oh, Aika, I want your voice, please. I don't want to call it a silent one. That belongs to Ivy Bird. So this is now 1 and 1 over 8. And that is the answer. All right? So I don't want no noddy here either. I want you answering me. Okay. Okay, so we know what we're doing in terms of that. Do you remember my saying that this could have been done using a second method? Why I don't want to use that method, especially with the primary school children, it's for this reason. Suppose we were given not 2, but 3 fractions. So we have a half, and it is, so we have, let's use this one, a different one with the denominators. So it's 1/8. So if we had 1/8, oh, this is going, so let's use another color. So we can have, it is 1 over 8, and it is plus, and then again it is 2 upon 3, and it is plus 3 upon 5. This gets difficult for the students if we're going to ask them to make each one of these mixed numbers, to make them equivalent fractions. And that is why I want to stick with an LCM, because then they're just using one number. All right? So it is for this reason that when we add another term to our 2-term addition fraction, where we're doing 3 instead of 2, then if we're going to still say multiply this time they will be doing 2 factors multiplying, and it gets messy. So we're dealing with our LCM. All right? So for this one here, it would be 8, and it is 3, and it is 5. And again, we start with the smallest number, and it comes from our times table. And then again, we'll be going 2 into 8 goes 4 times. This is an odd number. This is an odd number. So we know 2 would not go into 8 evenly without leaving a remainder. That's what we mean. So you try 2 again, and then it's going to go into 2, bring down out 3, bring down out 5. Notice what we are doing. If the number cannot be evenly divided into the other number we're dealing with, we bring it down just intact, okay? And then we can go 2 again, and we're going to get 1, 3, and 5. So we have used up all our 2's. Now, the next number we're going with, it is 3, because our aim is to get 1 as our last line, and that is 1, and that is 5. And so we have to go 5, and then so that is 1, that is 1, and that is 1. And then we know as long as we reach here, that's the end of the process for finding the LCM. And it is from the LCM that we can get our prime numbers, because we know what a prime number is, okay? So we can go 2 2s are 4, 4 2s 8, 3 8s would give us 24. And 24 times 5, don't do it in no brains if you can't. So you can write down your 24, and it's times 5, and you're going 5 4s would give you 20. Look at everything. 5 2s 10, so we're going to get 120. Notice I didn't try to look in no sky and try to do it. Write them on the little board, okay? After a while you will see these things. And here 120, okay? And you can go right away and say 8 into 120. You would not be given grade 3 numbers as big as this. I'm now stepping up into our first form, second form, or even our fifth formers, all right? Do not give them any big number like 120. Keep it simple because you want them with the concept. But what we are actually doing, we are starting from the beginning and taking you right up into your fifth form aspect of it, because it does not get any more difficult than this. All right, so right away we can say 8 into that, and we'll be left with 3 times 5, which would give you 15. Or you can go very slowly. You're saying 8 into 12 goes once, and 8 into 40 goes 5 times. For our fifth form students, we're saying we had 3 terms down here. It could have been 8, and it's times 3, and it's times 5. So if we're using up the 8, we're left with 3 times 5. That is how we know right away it's 15. And so 15 times 1 would give you 15. And then it's plus. Again, you can see the 3 denominators here. We're using up our 3. So we're left with 8 times 5. And 8 5s would give you 40. And 40 times 2, you can tell me right away, the answer would be 80. And here, we would have been using up our 5. So you're left here now with 3 8s, which would be 24. And 24 times 3, and that would give you your 72. So it's plus 72. Take your time. You don't have to try and see anything, any cross. No cross method. Put them down like how you're accustomed to and add them. So you're getting 2 and 5 would give you 7. 7 and 5, 15, and 1 would give you 16. So you have 166. So the answer here, again, you would have been getting, it's 167 all over 120. All right, we can choose to leave it like that, or we can choose to write it as a mixed number with a whole number and a proper fraction. But this, as long as they didn't say in its lowest term, you can leave your answer like that. And notice I took them off because sometimes you can't see this sliding around. Put them down onto each other, units, tens, do your addition and get it on and get what is right, okay? Fifth formers, notice the shortcut I'm showing you here, all right? The denominators, you had 8, 3, and 5. So you're writing down 8 times 3 times 5. When you're saying 8 into all of them, the 8s will go, and you're left with 3 times 5. So that is giving you 15, 15 times 1. When you're going 3 into all of them, the 3 will go, and you're left with 8 times 5. So you get your 40, and it's times 2. Again, you have 3 of them, and you're going 5 into this. The 5s will go, and you have 8 times 3 to give you your 24. And 24 times 3 would give you a 72. Notice these methods, all right? Because you can quicken and make shortcuts of some of your operations. So that is what we have to do when we're doing the addition for vulgar fractions. Again, today, we went into the whole aspect of tying off this thing with saying you don't understand how to add the vulgar fractions, and we said right away we have to bring them onto one foundation, and that foundation we call our LCM. We know how to get our LCM, put down our numbers, start from the lowest table, and we do not stop until we get 1 in our final row, get the LCM, and then do the division of each denominator into our LCM. Multiply the answer by the numerator, then do the addition and end up with our answer. We also found out along the way that we can be talking about, you see 2 terms that came up today. We had our terms that came up mixed numbers, not 2, 3, mixed numbers, improper fraction, and prime numbers. Teachers, look for these things. Do not glide over them. Stop to make certain that the vocabularies are understood and that children are just not using things and doing it, compartmentalizing stuff, but knowing that they can be used within other topics. Because the topic we're doing today is adding vulgar fraction. But these terms came up, you revise them right away. Okay, they're not stuck barrel and say they did that last term. Bring it in the front all the time. And thank you, grannies, because the more you learn these things, aunties, uncles, daddies, and the entire population, the more we'll sensitize ourselves. And people will stop saying, oh, you're Antiguans, you don't know mathematics. They're now going to be saying, oh, they're Antiguans and they know mathematics. Because suddenly you're finding out this number thing is something that I can conquer. And we are going to do it. So let us pray again for our nation, Antigua Barbuda. Let us ask God to restore the peace and quiet and comfort we once enjoyed. Remember to pray for the family of Sean Williams and to pray to Almighty God for somebody who had committed such a heinous act and wanton destruction of life. But the God of heaven will make certain that we can go on. Pray also for those people who have education at heart, and at the same time we take the opportunity to wish the Honorable Senator Winston Williams good luck in his new position and to welcome in the Honorable Mervyn Richards and hope that he will come down here very soon to bring our worry boards, because we still have the Center for Worry Education, but we are waiting for the tools. Thank you very much for viewing Mastering Mathematics. So from us here from ABU Unit Center for Mathematics and the Ministry of Education using ABS Television, do enjoy the rest of the evening.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.